Welcome to part 8 of our series on quadratics. Now we're going to move further with completing the square. Okay, we looked at a very brief introduction in part 7 and we're going to take that further now. We're going to look at expressions which have something slightly more complicated about them. So for example, the x coefficient might be an odd number. Okay, so far we've only looked at even numbers, and it might be that the quadratic starts with an x squared coefficient other than 1, such as 2x squared plus 8x minus 1. Okay, so I'm going to have a look at these three examples, numbered 1, 2 and 3, coloured in red, blue and green to correspond with the graphs that you'll see on the right. Okay, so I'm going to complete the square for each of these three expressions. Now we're still not solving equations yet through completing the square, but that step will come soon, and it's quite straightforward once you understand this, completing the square properly. So if we take the first expression here, number 1, I've got x squared minus 5x minus 8. Now what we would normally do is we would halve the x coefficient. Okay, so I'll do this one up here. So we'll halve the x coefficient, which will give us x minus, now we wouldn't normally write 2.5, we would normally write it as 5 over 2. Okay, and we do the perfect square. Okay, and we will, if we were to consider that, that would give us x squared minus 2 lots of 5 over 2x, in other words minus 5x, which we would expect. Okay, but then it would give us at the end plus 25 over 4. All right, it would give us plus 25 over 4. But we don't need 25 over 4, we need minus 8. Okay, so the first thing I'm thinking of is, what is 8 in terms of quarters? Well, it's 32 quarters, isn't it? So what do I need to do to my plus 25 quarters to get down to minus 32 quarters? Okay, well, the answer is I have to take away 57 quarters. Okay, so because 25 and 32 makes 57. So what I'm actually going to have here is that this expression here is going to be equal to x minus 5 over 2 all squared. Okay, but from that I've got to take away, well, I'm taking away 32 quarters, which is the 8, and I'm also taking away the 25 quarters, which, as I said, is 57 quarters. Okay, now 57 quarters is 14.25, if you want to think of it as a decimal. If you look at the graph over here and look at the minimum point, you can see that it has an x coordinate of 2.5. Okay, so this point here is the point, I'll just put a little arrow to it there, 2.5 or negative, sorry, 5 over 2, okay, 2.5, comma, and it is, you can probably see that it does seem to be 14 and a quarter, negative 14 and a quarter, which in fact it is 57 quarters. All right, so negative 57 quarters. We tend to work in fraction form like this rather than decimals. Okay, but it may help you to think of it as decimals. All right, so once again, as I showed you in the last video, completed the square form allows you to see the minimum point of the quadratic with its coordinates. Remember, the reason that this is 5 over 2 is because it's the minimum value that this bracket can take is 0, you see. So to make that bracket 0, what must x be? Well, it has to be 5/2. All right, and that explains that. And this is just exactly as you see it there. Okay, so that's the first one done. Now the second one, I'll just change to blue so you can see the working relates to the second one. Now what makes this one slightly odd, as you'll see in a minute, well, you can probably already see from the graph, there's something about this one that we haven't yet looked at with completing the square, and that is that the minimum point is actually up in the air there. It hasn't gone below the x-axis. Okay, so just to refresh your memory, that means that if you try to solve this equation, in other words, if it had an equals 0 after it, you wouldn't be able to solve it. But that doesn't matter. We're going to show that completing the square will give you the minimum point just the same. All right, so what do we do here? Well, we consider, I'll put it up here, what I'm considering is x plus 3/2, in other words, x plus 1.5, half of 3, all squared. And I know that that's going to give me x squared plus 3x, and it's going to give me a residue of 9/4. Okay, when I square the 3/2, I get 9/4. All right, so, but I don't want 9/4. I want the number 5, which is 20/4. Okay, so I would need to add to the 9/4 another 11/4 in order to get 20/4. Okay, so it's really helpful to think of this number at the end also in quarters. Okay, so I can say that my completed square form for this one is x plus 3/2 all squared. Okay, and it's going to give me plus 9/4 plus 11/4 as well would give me the 5. So I'm going to add the 11/4 onto that. Okay, and 11/4 is 2.75 if you want to think of it as a decimal. All right, so once again we can go over to our graph and we can see exactly what's going on here, because to make this first bracket 0, x would have to be negative 1.5 or negative 3/2. Okay, I think you can see there that that point is at negative 1.5, so it's negative 3/2. Okay, comma, and the height of that point above the x-axis is 1, 2, it's not 3, it's 2 3/4, 2.75 or 11/4. Okay, so even though the minimum point is above the x-axis, it makes no difference. The completing square still works. And in fact, if you completed the square for a quadratic and found that the y-coordinate of the minimum point was above the x-axis, you could conclude that if that were an equation, that it would have no solutions or no roots. Okay, so what happens when you get this situation in number 3, where you have a number in front of the x squared term that isn't 1, like this one here with 2? There are two approaches to this, and sometimes it's personal preference as to how you approach this, but I'll show you the ways that you could approach this, and maybe you can decide which you think is more is easier to work with. So what I'm going to do first is, well, let's just explore this a bit down here, because there's quite a bit to do here. So I'll leave that space there for the final answer, like I've done with these two, and I'll do my sort of investigation stuff down here. So I could start off by taking out a factor of 2 from the whole thing. All right, so I could rewrite the whole expression as 2 lots of, then I tend to put square brackets then, x squared, right, plus 4x minus a half. Okay, that's one way I could approach it. So I've taken out a factor of 2 from the whole thing. And that gives me, okay, well, let's start by just doing the completing the square of the bit in brackets. So if I look at the bit in brackets, I've got x squared plus 4x minus a half. So I'm going to consider that, so I'm just forgetting about the 2 for a minute, and I'm just going to consider the completed square of x squared plus 4x, x plus 2 all squared. All right, so let me go over here somewhere and do this. So so I'm in green, so everything in green is to do with this question, right? Okay, x plus 2 all squared gives me, okay, x squared plus 4x plus 4, all right? But what I need is x squared plus 4x minus a half. So I can think of the 4 as 8 halves, 8 over 2, but I need to get back to minus 1 over 2. So from the completed square, I need to subtract 9 over 2, 9 halves. So I could rewrite this as 2 lots of, okay, x plus 2 all squared. So remember that bit there, the x plus 2 all squared, is giving me this. So I need to take away from it 4.5 basically to get to this. So the 4.5 is 9 over 2. Okay? And remember, that's all inside this big square bracket multiplied by 2. Now, what you need to do now, if you're going to explore the minimum point of the curve, as we have done, you would now need to take out the, you'd now need to reduce the whole thing so that you're multiplying out the 2 with the 9 over 2. So you could say that is equal to 2 lots of x plus 2 squared, right? 2 lots of that. But now I've taken away the big square brackets because I'm going to combine this 2. I'm going to multiply this 2 by the 9 over 2 to give me minus 9. Okay? Now, that's the way I would present it here. Okay? So it's equal to, this is the answer here if you like, 2 lots of x plus 2 all squared. Okay? Minus 9. Now, look at the minimum point on the graph, okay, and you'll see that it is at minus 9, okay, and the number before it is minus 2. So it's negative 2, negative 9, okay, and so it's the negative of this, right, because that bracket has to be 0, remember, comma, what you see here, which is minus 9, which is there. So it does work. What confuses people is they think they need to do something with this 2. But when you think about it, all you're doing is setting this thing here to 0. So it doesn't matter if you've got a 2 in front of it or a 7 in front of it or anything. It's whatever's number is in this bracket here, it's the negative of that that becomes the x coordinate. Okay, just to finish very briefly, the other way I could have done this is just taken out the factor of 2 from this part only and left the minus 1 alone. I would have still ended up with this expression in the end. Okay, and that's it, because I get 15 minutes on these videos on the free software that I use to make them. So there we are, that's my 15 minutes up. Take care.